Welcome to the NCS4 Technology Webinar Series, where we focus on various aspects of technologies in sports and special event safety and security. In this webinar, we will focus on artificial intelligence. I'm Daniel Ward, NCS4's Director of Training and Exercise, and I'll be serving as the moderator for this session. AI brings speed, efficiency, and advanced analytical capabilities to security, making it an invaluable tool in the ever-evolving threat landscape. But what does that really mean to us? Joining us today to discuss just that from our Technology Alliance is Peter Evans, Chief Executive Officer and Director, Xtract One. Jumbi Edulbehram, Global Business Development, Smart Cities and Spaces, NVIDIA, and Ryan Zatolokin, Senior Technologist with Axis Communications. Thank you each for joining us. To get things started, I'll hand over the mic to Peter Evans to discuss purpose-driven AI.
Well, thank you very much, Daniel, and it's always good to be on another webinar with you and the team here. It's been a fun exercise. Of the 3, 4, 5 of us have all been talking through this, and I think we've all talked about it would have been great to record these conversations. So here we are today. I'm going to start with a little bit of kind of background and history, and like, why is it that AI is so hot today? Well, the fact of the matter is AI has actually been around since the 1950s, and even slightly started during World War II, when folks like Alan Turing first started envisioning, can machines think and reason like humans? You know, Alan Turing was a mathematician, and there were mathematicians, statisticians, and philosophers even, who started to think, like, could we actually develop machines to think and reason like humans? And what Alan Turing proposed at that time was, look, if I can take what humans do, taking available information as well as the ability to reason in order to solve problems and make decisions, then why can't, if a human can do this, why can't I mimic this with a machine? Right? So the question is, like, why not? You know, it seems like infinitely possible. And let's think a little bit. The world was a little bit different back then, but Turing did in fact invent his Turing machine that actually was able to, you know, crack the code of the Enigma machines of the Germans during World War II. So the art of the possible was there, but the ability to actually deliver at that time was not there. So while folks like Turing had this vision about how to create reasoning machines, there were a lot of challenges to be able to do that. You know, talk is cheap, as they say. So what stopped Turing and others from getting there? Well, first off, computers themselves needed to fundamentally change. Computers lacked the prerequisite for intelligence. They couldn't store commands. They could only execute them. You could tell a computing machine what's 1 + 1, and it could calculate 2, but it couldn't store that knowledge, couldn't store that history or that information and be able to use it to advance its thinking capabilities over time. Secondly, you know, at this time, 1950s, computing was incredibly expensive. Moore's law hadn't played out yet, and only very prestigious universities or big technology companies could potentially afford to have the computing resources at their disposal so they could explore and test with these kinds of environments. You know, there was lots of proof of concepts and advocacy, but there wasn't really the ability to create machines that could actually reason and learn. Only those that could react and perform a command on behalf of those who instructed them. So there's a bit of a history here, and if we kind of play with this a little bit, we can actually see how we got to where we are today. So if you look again at this history of AI, it's been around conceptually for 70, almost 80 years. And there's been sort of key milestones upon the path that have actually set the course for what we are experiencing as AI today. Without some of these investments and some of this innovation, we might be on an entirely different path with AI. There were things like, you know, where folks wrote, you know, documents. I read a great, interesting document by a couple of guys named Cliff Shaw and Herbert Simon called The Logic Theorist. And if you think about what they were writing about many, many years ago, it's actually what AI is today. So like the science fiction writers, Isaac Asimov and others from many, many years ago, these folks could see the future. They just didn't have the tools to get there. As we started to kind of plow our way through the 50s and the 70s, 50s, 60s, and 70s, AI actually flourished. There was a lot of investment in new computer technology that could actually store much more information, become much faster at much more cheaper levels, and become much more accessible to a larger group of people. So as the snowball effect started to take place with more and more people investing and spending more time, we actually start to get things like learning algorithms or machine learning algorithms that could actually improve, and people themselves tried to know which algorithms to apply to which problems. And so we saw a lot of work there such that organizations like DARPA actually likes to fund AI research in many different institutions. The challenge was, though, that computing processing power was still very, very expensive, and things sort of stalled into the 80s. It was really kind of post the 80s when AI was reignited by a couple of different sources. The first was there was an algorithmic toolkit and actually a significant investment in funding that actually led to the popularization of things like deep learning and those kind of techniques, which allowed computers to move beyond just reacting to commands, but actually storing information and starting to learn from those experiences and those learned experiences. So what does that mean to where we are today? Well, we're starting to see a lot of interesting things where you're seeing things like back in the 90s where you had Gary Kasparov actually being defeated by IBM's Deep Blue machine. It's a chess playing computer program, which was actually learning from every one of Kasparov's moves and actually using that knowledge to change its algorithms in order to be able to beat him in successive matches that he played. Going forward a little bit, where are we today, right? We haven't got too much smarter about how we're coding artificial intelligence, but we've been able to apply computing power to it to be able to actually do more faster in a real time. And that's why we're seeing things like the AI algorithms that beat Gary Kasparov. We're living in the age of big data, and it's an age where we've got the capacity to grab huge sums of data, right? Information that is too cumbersome for the human to solve. And we think about kind of the human AI interaction. Machines are very, very good now. They have the processing capacity, they have the access to big data, and they have the capacity to collect and process huge sums of data, hundreds of thousands of data points, millions of data points. And so machines are very good at taking large amounts of data and kind of bringing it down to the one or two or three pieces of critical information that are required to make a decision. But humans, on the other hand, are very, very good at taking just two or three pieces of information and actually providing a very good decision out of that. So the combination of kind of what AI promises plus humans or humans in the loop actually creates a very powerful combination. And where humans are fallible, there's no way a human can sift through billions of points of data and actually do all that correlation himself without making mistakes, right? We can actually overcome that problem with what AI does. But you have to mind the gap. Taking a page out of kind of what we see in the British subway system. That train that's moving in the subway system, if that is an AI train, it's moving infinitely faster than what we've experienced before. We had the same sort of problems as the world started adopting the internet as a tool for communication, for collaboration, and for commerce. When the internet started racing out the door and we started using it more, people started to worry about personal privacy. They started to worry about cybercrime. They started to worry about hacking. They started to worry about all these different applications and how we would police the use of the internet to make sure you didn't have things like hate language on the internet. In the same way that we had those same sort of challenges and policies had to catch up with the internet, the same thing's happening with AI. And we're finding issues such as, are AI engines biased because of how we're training them or who's training them? What about data privacy information? If we're putting billions of points of data into an AI engine, how do we correlate that? How do we manage that? How do we police it? Has the horse left the barn far too fast and much faster than what we experienced with the internet? So there's a huge gap here. And if we don't mind it, we're going to get jammed in between it and dragged by that train. So, when I kind of look at the world of software development and when I look at what we're seeing happening with AI, we're starting to see some of the same behaviors that we see with a lot of different industries. Oftentimes, we as a technology industry are inside out driven versus outside in. We as technology companies tend to develop very interesting ideas, very interesting AI algorithms as an example. And then we start taking those and looking for a problem to solve. And oftentimes there's kind of a square peg round hole problem. And it's why there's been a lot of disappointment about things like AI. A lot of promise that goes unfulfilled. And like Gartner's hype cycle curves that we often see applied to many different technologies, we've gone through periods of excessive hype down to a bit of a trough of disillusionment, but now we're starting to see pragmatic applications of AI. And the difference there is it's AI that's been purpose-built to solve a specific problem. And oftentimes that purpose-built solution starts with 3 layers. I like to simplify it down to 3 layers as I think about things. You need problem-specific data. It's a different data set if I'm looking to drive more revenue out of a casino versus I'm looking to enhance the patron experience in an arena. It's a different data set that's purpose-built for a specific problem and gathered for that problem. On top of that, I need a purpose-built AI engine. I might be doing different things to analyze different data to solve a different problem. And then I have to present that information to the consumer or the user or the operator in a manner that's usable to them. So a simple example, let's say I've got a casino and that casino wants to go double the revenue from the slot machines. The data might tell them things like, well, the average person sits at a nickel slot for 27 minutes, but a dollar slot for 47 minutes. So how do I use that data, and what algorithms can then take in just information, watching people and traffic and movement within the venue, within that casino? And then based on correlating that engine, there might be things that come out of it that say, okay, I'm going to present information to the wait staff, for example, who are giving free drinks over at the dollar slots to entice people to move over there. It really depends on the purpose, the problem you're trying to solve, and having the data, the engine, and the presentation layer to make meaningful information out of it. I think we're starting to see that in the AI world today. We're starting to see the rise of AI pragmatically applying itself to solve specific problems. The one thing I always caution people against, and this is from someone who's an engineer who spent a lot of time in marketing, be careful. The primary driver for marketing individuals, such as myself in my prior role, was to drive as much traffic to your website or people through your trade show booth, or you name it, to drive your brand or drive your stock price, as the case may be. And so we start to see many, many times these kind of key critical words like digital transformation, big data, the metaverse, extended reality, and now these days AI being applied to everything we do. Be careful. Are you truly driving an AI-driven problem to solve a problem? I personally expect to go down to my local grocery store on the weekend one of these days and go find my box, my favorite laundry detergent, my favorite breakfast cereal, whether it's cornflakes or whatever, and it's going to have a big logo on it that's going to say now with AI. Be careful about marketing. Focus on the problem you're trying to solve and look for the solution to solve that problem, and don't get distracted by all the hype that's out there. There is true value for AI when pragmatically applied to specific problems.
Thank you, Peter. Now for our next section, Jumbi is going to dive a little deeper into what AI is.
So, just to clarify at a high level, as Peter mentioned, AI has been around for a very long time, and it's basically, the effort to try and get machines and computers to behave more like humans. So at the highest level, AI is the ability to train a machine, to train some algorithms, to try and make decisions like human beings would. And along the way, machine learning and deep learning are kind of steps along the way to get there. Machine learning, of course, being training computers, training machines with a set of algorithms to, do things that we want them to do, kind of like, a calculator, for example. But then deep learning is where you really start training these machines, training a computer to do things like humans, because the data sets that we feed them are processed by neural networks, which is essentially what humans have in their brains. So these neural networks now get us these new AI techniques to get computers to make decisions essentially more like humans. So as you can imagine, these days AI is used in pretty much every industry out there. And, there are a whole range of super interesting use cases for, of course, safety, security that, all of us work with. But even things like traffic management, frictionless retail, where you can walk in, pick up whatever you want, and just walk out the store. Healthcare to actually monitor surgery. And of course, creating really interesting shows like The Mandalorian, which was actually created using a lot of AI graphics technology. And, AI is even behind a lot of applications that you might not necessarily see or think about. Like, for example, when you get recommended songs or videos or products, etc. A lot of those techniques in the back end these days are also based on AI. Now, human beings are obviously still a lot smarter than computers, but, we do have some flaws. So we occasionally need help from machines. So I actually like to call AI, I think Peter kind of alluded to that as assistive intelligence rather than just being something artificial that's trying to take over from something real. So, these are some things that human beings aren't great at, right? We aren't great at paying attention to really boring stuff. And especially these days with so much information coming our way, we're getting less and less attentive and being able to pay attention if nothing's going on. And then, of course, I think, Peter mentioned this, we're not designed to process massive amounts of data simultaneously. So this is where AI comes in, and this is why, I like to call it assistive intelligence rather than artificial intelligence, because it helps us, deal with some of these flaws that we have. So at a high level, all of AI essentially consists of two parts, one which is training the models, and one which is inferencing, which is actually doing what we need it to do. So training is where you feed large amounts of data to these computer models, to the neural networks, so they can learn a given task. And inferencing is where you actually deploy these models in the field so that they can do what you want them to do. So I'll just show you a couple of slides to quickly illustrate how this works. So to train a model, for example, to recognize cats, you of course have to give it lots of images of cats and many, many different kinds of cats, so it recognizes a cat under all circumstances. But that's not good enough, because what you then need to do is give it lots of pictures of stuff that's not cats. For example, dogs that could actually look a lot like cats. So you want to keep refining your model. And then, of course, when you deploy these models in the field, you want to keep collecting new data so that the model gets even more and more accurate, because in the field, there could be a cat in a forest, there could be a cat in a field, there could be a cat in a tree. You have to be able to recognize cats under all these circumstances. So you have to keep retraining and refining your model. Yeah, so this is what this slide illustrates. So when you actually sort of deploy a model in the field, so to give you sort of a more sort of security related example, if you're trying to detect a person jumping over a fence, of course, there are many different kinds of fences. There are all kinds of different things and animals that might jump over a fence. You've got to do that recognition under a range of different conditions, fog, rain, snow, etc. So you have to constantly collect new information, train your model, and redeploy the trained model. So, what are the challenges? I mean, there are a host of challenges in AI, but this is kind of the more sort of practical challenges of developing and deploying AI. One which is, of course, it needs a massive amount of data, especially if you want to create really accurate models and get really accurate results in the field. It all starts from creating large data sets to train the AI. Secondly, of course, a lot of computers out there are based on CPUs, which aren't particularly well suited for running AI. And the third is, a lot of the software infrastructure for training, for deploying, for managing can sometimes get complex, right? So current, IT staff, etc., aren't fully trained on the new techniques of AI. So sometimes that could be a challenge. So, this is just an illustration of what I mentioned about CPUs that most computers have, not being great at processing AI. So this is an example of a video processing application where a CPU was able to process 7 streams of video. And this is for a real use case, a real application. And then when that same application was ported and run on a GPU, we get 10x the performance, because, parallel computing hardware and software unlocks much, much greater potential for running a whole range of different kinds of AI algorithms. Yeah, so, these days, there is so much work going on AI development that, we've really come to a point where even creating, complex AI applications, for example, an intelligent virtual assistant, which is where, you can ask it questions, it understands what you're asking, it'll look through a massive database of possible answers, and given the context, give you the right answer. You don't have to create all the parts and pieces from scratch, right? There are a lot of modules now available that will allow you to basically follow a recipe to create these kinds of even relatively sophisticated applications. So, a large number of use cases are enabled by AI. Of course, the ones that we commonly think about, the video analytic kinds of applications. But here I show some of the others, virtual assistants, audio transcription, which is really useful, for example, for transcribing, 911 calls. Cybersecurity is a huge issue these days. So all these models now can be created using reference applications. And, as Peter mentioned earlier, a few years ago, we didn't really have hardware that was sophisticated enough to deploy these AI models in a cost-effective way. But these days, everything from, super smart, cameras at the edge where you can actually run AI, to servers, to data centers, to the cloud. I mean, the deployment options using intelligent devices is pretty vast. So, you want to make sure you use the kind of AI which gives you the flexibility of deployment anywhere from the edge to the cloud.
Thank you, Jumbi. And to discuss the deployment of AI at the edge and IoT, I'll hand it over to Ryan Zatolokin. Ryan?
Thank you. Yep, thank you, Daniel. And really to leap off of what Jumbi had just gone through, we have a lot of sensors out there in the world. And one of the sensors that I think we have the most of is video cameras. So looking back in time, I mean, we could do some early processing without AI in these devices, things like video motion detection, which were really just looking at pixel changes, not very intelligent, not very adaptive, but with the ability to put actual deep learning processors into these devices, we can do some pretty amazing things. The idea here is we need to first start with a very good picture. The capabilities of more advanced cameras lend themselves to things that we wouldn't normally see, like seeing in situations where they're maybe extremely backlit, where we want to see maybe this person's face, or to just get the right contrast and color out of the scene, as well as scenes where maybe the camera itself is shaking, trying to make sure we have the proper image, start running that AI against, as well as situations where they may be very dark, making sure we're pulling all that detail of the picture. All of that really contributes to making the results of this much more usable and much more accurate overall. Of course, the biggest thing we want to avoid, and this has been a long time problem in the IP surveillance industry, is avoiding false positives. When we start using different analytics, we don't want to instantly keep receiving, hey, something's happening when it's not, because people will start to ignore that completely. And with AI, we have much more information to work with. Matter of fact, the ability to classify whether it's a car, whether it's a truck, a bus, a motorcycle, allows us to really hone in on details that before we never had. In addition to that, if we're looking at a situation where we can identify people in a room, just the identification of those people in that individual room lends itself to the ability to count the people in that room. So it really opens a whole lot of new things that we can do. that we're never able to do at the edge before. How about combining that information from those different sensors together? So the ability to see how far away someone is, to actually what their geolocation is based off of knowing the radar's geolocation, the speed they're traveling, and of course, are they a car? Are they a person? Being able to combine all that data together, give us a bigger sense of what's going on. And of course, being able to, with that, just gather more information, filter out especially those things we're not concerned about, and alert on those things that we are concerned about. Of course, not everything can be done at the edge. Of course, simpler things, classification, person, animal, car, motorcycle, those type of things, we have great ability to do. Even things like counting the number of people or the number of cars can be done at the edge of the processing capabilities we have there. More advanced things like facial recognition, more advanced analytics, of course, will require a server, an on-prem server, or cloud services to be introduced to do those things, to make those comparisons. This is where I think the real ability of using hybrid solutions comes in place, because depending on what your use case is, depending on the problem you're trying to solve, there are many options out there today that you can utilize. Really, in the end, capabilities in edge-based or those devices that are at the edge that can do AI, such as cameras, radar, and so on, are coming up quite a bit. More processing power means more capabilities in the future, and the ability to choose between an edge or on-prem or cloud solution allows us much flexibility. The idea is to have open platform where we can exchange data, make it easy to use, make it flexible, and also make it reliable as well. And that was kind of a quick look at the edge itself.
All right. Thank you, Ryan. And thank you all for your insights. It was really helpful to kind of understand the history of AI, why AI has to be purpose-driven, some of the foundational components of what makes AI, and certainly understanding the application within the security industry. I know I, for one, learned a lot just in this last 30, 40 minutes or so. So the next thing we wanted to do is ask a couple of questions. We know we're always getting questions about AI. I know you all get questions from practitioners about AI and the application of AI. So I had a few questions I wanted to pass along to each of you and discuss it as a group, to have a little conversation around these topics. So the first question I have is for you, Peter. I know one of the things we mentioned was patterns. Is it AI or is it pattern matching? That's one of the questions practitioners like to ask as they try to understand what AI is and how AI is working for them. So if you could talk a little bit about those things.
Yeah, it's a great question, Daniel. And you see this a lot. It comes back to kind of confusion and back to some of the earlier points that everyone was talking about. The idea of AI is, to a certain degree to mimic what the brain does, a human brain. It's the ability to gather a lot of data points, to reason, to make decisions around that. And so, in some cases, pattern matching is looking at the shape of an object. And, I think Jumbi used the example of a cat, right? And there's certain kind of criteria or characteristics you might look at. It's a cat. It looks like this. It's got whiskers. Its ears are this shape, right? But, is that just matching a pattern, or is it AI? And there's a degree of reasoning in there. So I think it really comes down to a bit of the application you're trying to solve. Nothing wrong with pattern matching. We all do it every day, right? But as humans. But I think that, true AI kind of takes it one step further. You're not just saying, here's 1,000 things go by and that one looks like this, therefore alert. In our case, in the weapons detection world, there's a lot of people who use the words AI, but really all they're doing is saying, okay, I've seen this characteristic, therefore alert. But is it this characteristic of a weapon, or is it this characteristic of a gun, or is it this characteristic of a laptop, or is it this characteristic of X, Y, Z? And it's that next level of thinking capability, I think, differentiates AI from pattern matching.
Thank you for that, Peter. Any additional thoughts on AI versus pattern matching from you, Jumbi or Ryan?
Yeah, I just Peter makes a very good point. I mean, they are somehow different, but in a lot of applications, you can actually use them both really well. So for example, if you want to ask a computer a question, and if you wanted to really understand what you're saying, understand the context, it requires a certain level of AI and some natural language processing and training. And then if you want the computer to just go look up a manual for the information that you're looking for, that's pretty much pattern matching. So in a lot of applications these days, those are actually being, combined very successfully for, all these interesting use cases.
Thank
And I
you.
would just add to that as well that using, whether it's pattern matching or actual AI, the accuracy and the analytics that utilize both in many cases has gone far, far up in the last few years. Just much better results, much more reliable. As operators who use the systems will tell you, if they're getting false positives all the time, they're going to start ignoring those very quickly. So the reliability being higher has really contributed positively to the video surveillance world.
Yeah, I think that's a real good point, Ryan, if I could jump in on that. And I think it comes down to, particularly again, what you're saying in video surveillance, it's kind of that extra level of reasoning beyond just, sort of counting or looking for patterns. It's like, is this something that's truly meaningful or just something that I've seen before?
That's great. Great feedback. And I know it's extremely helpful to understand the differences because it can get confusing at times. There's a lot of information. This is a challenge for our industry and discerning between pattern matching AI and how those things can work together successfully. So the next question I have, I'll start with you, Jumbi, is what are some of the concerns around biases of AI? What types of biases might we encounter with AI, and what should we be looking out for?
Yeah, that's a great question. The biggest, I guess, there are sort of different aspects of this bias question, but the one that people think about the most are the biases in the training data that are used to train the models. So if the training data is biased, obviously the decisions that the AI makes is going to be biased. And the very sort of common example of that is if you don't train the data on facial recognition for a particular type of face, then obviously when you actually do the inferencing, make decisions, it's not going to work too well for those types of faces that weren't a part of the training data. So what's important is the transparency in, whatever training data are used to train the AI. And of course, I'll just add to that, there are also issues around, obviously, privacy. So regulations like GDPR and stuff, you got to make sure you comply with those as you're building your training data sets. And then the last, big issue is data sovereignty. So, the question is, who actually owns the data that's being collected, especially, if the data is being collected in the public domain. So, I really think, human beings are obviously smart enough to figure out, how to deal with these issues and at the same time, get the benefits of AI, because that's kind of been true for every sort of big technology revolution in human history.
Thank you, Jumbi. Any other thoughts on concerns surrounding biases from you, Peter or Ryan?
Really just say it really comes down to the scoping, what you're trying to do too. At least what I've seen with AI, it may not be just directly into the biases, but if you don't have the data there, it's going to make assumptions. It's going to try and match up to what it knows. So I think really that training becomes so important, and then the scope of the problem you're trying to solve.
Yeah, I have to agree with that, Ryan. And, I think Jimmy is a good point. All AI engines and all machine learning engines have to be trained, and they get smarter and smarter over time with more and more training. But, there's something in there that sort of has to kind of indicate to the system, this is, in our case of our business, this is a weapon, this is not a weapon. And, the systems have a degree of self-learning, but there's also, again, back to that idea of a human in the loop that says, this might look like a weapon, but it's not actually a weapon. And at some point you start to say, well, where do I get enough data to train the system? let's say you're training an AI system on cameras to go recognize this is a fight or this is a crowd disturbance, for example. Well, who's to decide, right? And is it a fight? If I've got a bias to, you know, this demographic versus that demographic, to call this a fight and that not a fight, you know, where do you kind of remove those biases? The more that we can automate things and let kind of almost the AI manage the AI, I think things become better because it gets scalable and more data and a larger data set by which to make intelligent decisions around.
Thank you for that. Thank you for that. All great insights, and it's again extremely helpful to understand these things and understand that AI will get smarter with the more data over time. The next question I have is, I'm going to start with you, Ryan. This next question is, what's next for AI? What does the future of AI hold? What are some of the things that you're seeing that practitioners should be on the lookout for in the pipeline?
Well, I think if I look at it, without getting too specific, I think more open platforms, more industry standards around this, and better efficiency all the way around for AI video analytics. Keeping them flexible, keeping them compatible, and then also just continuing to introduce that seamless way to work between edge-based, cloud-based, or even server-based, with the idea that all the processing and all the capabilities of each one of these things is going to get better. Especially, I think, in my particular domain of experience, the edge, being able to put more processing, more compute, more storage out at the edge, be able to do more complex tasks, but of course not as complex tasks as maybe that server or cloud solution. So just a general broadening of the offering, just as we've seen it broaden from in the last few years, especially for edge devices.
Thank you, Ryan. And I think it's important you mentioned your specific domain and your perspective. Each of you have a different perspective and a different experience with AI. So, Jumbi, from your perspective, what do you see as the kind of the next steps or the future of AI?
Yeah, I think, from where I sit, we've just like barely even scratched the surface. I think the biggest thing happening right now is, as I'm sure everyone's kind of heard or at least experiences to things like ChatGPT, is what we call generative AI. And so what will, that really allow us to do? Just like people use it for ChatGPT, which is a language application, man, it'll allow us to create anything you want, objects, pictures, even buildings. You could say, build me a building in the style of XYZ and give it the parameters and it'll build something for you. And actually, to Peter's earlier point, it'll make creating training data a lot easier because it'll be able to create millions of faces instantly by varying every single parameter on the face. So you can use that for training. Similarly, for different kinds of weapons. Secondly, it'll allow us to automate a lot of tasks which are right now, done manually. So for example, imagine it analyzing all the video all the time without you actually telling it anything. And then after a while, you should be able to go to it and ask it to look for whatever is interesting, which is the third thing I think it'll allow us to do, which is have a natural language interface to pretty much any computer or any machine. So rather than having to, type stuff, etc., you should be able to just talk to it and say, hey, show me every time a person, walks through the door, and boom, it should be able to respond to that. So I think all these applications, super exciting applications, are going to be enabled by generative AI.
Thank you for that, Jumbi. Peter, what are your thoughts?
Well, there's sort of two or three things that come to mind, Daniel. Some of those things that people think are some of the weaknesses could actually be a strength. For example, we just talked earlier about being cautious about the biases of AI. Well, the nice thing about AI is, if done correctly, it can be entirely unbiased. And I think every day, every one of us sees all sorts of stories on the news that now have biases to them, depending on who you are and what your interests are. We see this particularly in the political realm these days, unfortunately. So do we start to get back to a world of, truth in advertising, truth in media, truth and things like that? Because you've got it coming from an unbiased AI system, right? Which is very objective in nature. So I think that kind of has an interesting promise to it. The other thing that I think is, we talk about purpose-built AI and pragmatic applications. I have to have the right data set with the right AI engine to solve the right problem. But where I think where the real power is going to come in is when you start to see things correlate, right? And so think about it from, what NCS4 stands for and spectator and stadium security. As they start to gather information from AI engines that are looking at things like, identity theft or cybersecurity risk or weapons screening or flow of people traffic within a venue, they start to see that integrating for a much more kind of end-to-end, like complete value chain approach to things, not only for guest experience, but also for guest security. I think you start to get really powerful, multiplier effects here of, taking all the AI that exists on the billion cameras that Ryan talked about earlier. So what you're doing with weapons screening, what you're doing with, patron traffic flows to create an entirely different set of proactive experiences. So I think we're just scratching the surface of what the promise here is by, we're solving unique problems when they all come together for a complete solution. That gets interesting to me.
Thank you for that. And it's great hearing the various perspectives and thoughts and ideas on AI, where it stands today and where we see it going in the future. I know artificial intelligence has just become such a polarizing term that I think it was great to be able to sit down with you all and demystify some of that and help our audience to understand a little bit about what AI looks like today and how they might encounter it within this industry. So before we conclude, I did want to just open the floor up for reattacks or any additional tips or tricks or food for thought for our practitioners in relation to artificial intelligence. Ryan, I saw you just came off of mute. What do you have?
Well, I think it goes back to Peter's point originally, which was just because it says now made with AI doesn't necessarily mean it just because of that. It's better, but it is definitely opening some new possibilities that we didn't have before. Just the way we've seen, or I've seen the IP surveillance world, it's definitely the accuracy of the analytics is much higher when used properly, when trained properly, and when looking at a specific task that it's trained for. So I think that is where I see it working really well. We'll solve every problem today, not every problem, but I think the future is very bright as far as how it goes.
That's great. Thank you. Jumbi, I saw you came off mute.
Yeah, what I would encourage everyone to think about is, look at all the tasks that you do, your company does, your organization does, etc. And really think of, again, AI as an assistive intelligence system that's going to help you do what you're already doing, quicker, better, faster. And of course, there's a whole realm of stuff of, new capabilities that AI can bring. But I think just in general, across society, we're going to get the biggest bang for the buck for making our existing tasks and, whatever we're doing as individuals, as organizations, as families, etc., much more efficient, much more cost effective, whatever you want to do. So.
Yeah, I like that idea, Jumbi. I'm looking forward to the day when I just have my AI engine answering all my emails for me. Life will be so much better.
Exactly.
Yeah, thank you for that. Any reattacks from your perspective, Peter?
No, I think we've covered a lot today. I don't really have anything more to add to it other than what, Ryan and Jumbi said. I mean, we're just barely scratching the surface. There's, the ability to, have the human mind focused on, the complex tasks and let AI deal with, the whirlwind that consumes us every single day, I think is going to, help us be much better overall.
Thank you all so much for participating in this session. I know it was extremely educational for both myself and practitioners across the country who are grappling with AI and trying to understand its application. So thank you again. Thank you all so much for your time today.
Absolutely. Thanks,
Thank you.
Andrew.
Thank you.
Pleasure. Take care.